Okay, so welcome. This is the last week before our Easter break, so that you have a good idea of what's going to happen. We will have 3 weeks of Easter break now, during which the lab will be open on an open access basis. So if you do want to come and catch up on your work, you can, and you should really. I think the labs and the university in general will only be closed on Good Friday and Easter Monday. All of the other days, the university and the labs will be open and you can come in and work. Okay, when we come back, we'll have essentially 3 more weeks of labs. So we'll have 3 more weeks in the labs where you can get help from us. And then finally, we'll have the 4th week of classes of the teaching block, which will be assessment. So I will sit with you and I will check all of your logbooks and the work that you've done on your computers. So with regards now to where we are working on the last lab sheet, which is more of a glorified coursework rather than anything else. If you have had a look at it already, I do have instructions on how to set up NFS and LDAP that you can follow in order to do this. I also have an LDAP commands file. This is much easier to follow rather than the link on this, because I've changed the domain names in there to correspond the correct ones for our computers. So there's much less, well, there's 0 editing required on your part. So if you're going to do LDAP, follow that text file. There is also some information about contextualization and Open Nebula groups. The reason why you need all of these is because these are the tasks that you will need to complete in order to build your cloud. So the order in which I would like you to do those tasks, to perform those tasks, is as follows. So after you've finished with the obvious labs, then you have all your networks and everything, the first thing that you should do is take vPrometheus 0 and remove the DVD image from it. So you need to go to the template, you need to go to storage, and remove the CentOS DVD image. You've built the virtual machine, you don't need to build anything else anymore. There's 5 gigabytes that have to be copied every time you instantiate and deinstantiate a running template on your cloud. So that's a lot of space that you don't need to be taking up resources. Okay, so delete the DVD from it so that every time you instantiate the virtual machine, you only have to deal with the size of the actual physical hard drive that you have in your virtual machine. You will then need to clone this virtual machine 3 times in order to create your server, your lecturer client, and your student client. Okay, when you do that, when you click on clone template, it gives you the option to clone with image. So if you do that, it will take the images that are saved in your data store and it will make a clone of them, it will rename them appropriately, and it will allocate it to the new correct template as it is. This is the fastest and most efficient way to create duplicate virtual machines for your cloud. One thing that you have to change in here, you will still need to go into those templates and you'll need to change the network cards. All right, so your VP0 template was using net28 or whatever it was, whereas your 3 new templates will need to be using net28, net30, and net31. Okay, now once you do that, you need to power up those 3 virtual machines, give them the correct networking information in there. So you need to actually configure the network cards with the correct IP addresses as they should. And then I want you to ping each other so that you make sure that they can ping everywhere. Ideally, you should have routing running, so they should be able to ping google.com from all of the virtual machines. More importantly, you need to be able to have server-client interaction. So you are going to set up your VFS with some services, namely at the bare minimum NFS and LDAP. You need to make sure that you can actually access those services from your clients. So before you try to set up any services on your machines in the cloud, do a quick check, try to ping the server from your client and make sure that you can actually get a response back. All right. Once that's sorted out, then you need to set up NFS on your virtual server and set up the clients so that they can mount, ideally automatically through FSTab, the folder that you're sharing onto your server. This should be able to happen both on your VM lecturer and on the VM student as well. Once you do that, you should set up LDAP as well. So again, same principle applies. LDAP will be set up on the server and VML and VMS need to be set up as clients that are configured so that their authentication method is through LDAP on that particular IP address of your server computer. Once you do that, you will need to also create users in that LDAP directory. So you will have created an example user to begin with. You need to add more users like that. And those users need to be some lecturers and some students. So it's a good idea to make a plan and say I'm going to have, I don't know, three lecturers, 3 students, just so that I can test everything. Okay. You can use whatever passwords you like, although really I would prefer that you use localhost 1 for all users everywhere always, because we're already struggling in the labs with people that have used their own passwords in virtual machines and have forgotten about them. Okay, so please use localhost 1, all right. And you should be able to authenticate as student A, student B, student C, only from your student VM. Only from VMS. Okay, I shouldn't be able to log in as a student into one of the VML machines. There are lots of ways that you can achieve this. The easiest and most straightforward is for the student or the lecturer accounts to never have access to the lecturers or students' machines to begin with. Okay. So the easiest way to do this is to actually sort out the permissions and the access control lists in OpenNebula itself. So you need, that's step number 8. So you need to go to Sandstone, you need to look at your virtual machines that you've created, and you need to allocate them to groups of users. So the VML should belong to group lecturers. The VMS should belong to group students. That way, if a student logs into the cloud, the only virtual machine that they will see and be able to start will actually be the virtual machine, the VMS that belongs to students. Okay, we don't want to have users to be able to log in across different types of virtual machines in the system. All right, so the most straightforward way is to do this. Yes, you do need to configure the users twice. So you need to configure the users on the LDAP directory internally on the virtual machines so that they can log in from one virtual machine by using the authentication to the server, and you also need to configure the same user accounts onto the cloud itself in Sandstone so that you have the control with regards to who can log into which virtual machine. Okay. Now, once you do that, you assign all the templates to the correct users and so on, and then you need to test permissions by logging in as your students. Okay, I only need to see one screenshot of it. It's not important that you test all 3 of them. Okay, log in and see what you actually get when you log into your Sandstone OpenNebula web interface. All right, if it's a student, you should only be able to have an instance of VMS. They should be able to start it, and that's it. Once you achieve this, then you have reached what I call a baseline setup for this lab sheet. Okay, so at this point, I will give you up to 70% for this lab sheet as well. All right. Now, if you want to achieve additional marks in this, ridiculous cars, this coming from a very, very car guy like me, yes? Never mind. Right, so, additional marks, things that you can do. Add contextualization to the VMs with regards to their networking. All right, we won't really help you with this too much, and it should be very straightforward, and it should only just be one box that you check somewhere in the template. Okay, why do you need this? You need this because when you start your virtual machines, when you instantiate them, if you don't contextualize the network settings that you've given to it in Sandstone, the virtual machine itself will not have a configured network card. Okay. So yes, the cloud might know what network information, IP address, default gateway, and everything else the virtual machine should have, but the operating system of the virtual machine itself will not know. All right, unless you actually enable the contextualization, and it will. You can also add other contextualization features in there as well. You can set the virtual machines to do things at startup. You can run whatever script you like in there, and it will do it. You can pass through SSH passwordless authentication through it. and so on and so forth. There are lots of things that you can do. If you go to that link on Moodle and have a read about it, you'll see, you'll get some example, you'll get some idea of what you can actually do with that. Second bit is the networking. So you will create multiple users for students and lecturers. However, on the current IP address scheme that we are, you actually don't have the ability to start multiple virtual machines at the same time for a particular group of users. All right. So the lecturers on subnet 30, for example, can only start one virtual machine at a time because basically we don't have any other IP addresses. You only have 2 IP addresses per computer because of the subnetting that we've done. If you want to take this little project further, you can find a solution to the lack of IP addresses. Try not to use other people's IP addresses. All right. The easiest way out of this is private IP addresses. 192.168.172.10, 10.0 something, whatever you like. To do this, you will need to create a new bridge in OVS. That bridge can possibly only have one port. That will be the new network card that you will create by creating a new text file ifcfg-en private or whatever you want to call it in the etc sysconfig network scripts. Okay, and then you can actually NAT that network by a simple NATing iptables command on Prometheus itself. And in fact, I think I don't have this here. I will include the iptables command on a text file so that you know what it is. Okay, so the easiest way out of this is this. So you create a new network card physically as a configuration file in the system. You create its OVS counterpart, and then you start it up. Once you start it up, you create it onto Sunstone as well. You give it the range of addresses, so in this case it can be an entire class C network if you like, and then you simply instruct the virtual machines of that particular group, let's say the students or whatever, to actually use that network card, that private network card there. This way you can start as many as you like and have as many users as your cloud can support. So now we're removing the limitation of the IP addresses that we can use. However, now we're going to reach other limitations in your system. Okay, how many CPU cores you have available in your cloud and how much total memory RAM you have available in your cloud as well as hard drive space. All right, all I need you to do is proof of concept this. You don't need to actually try to start 10 virtual machines and have 10 students connect at the same time on the system. Okay, I can assure you it will bring you to its knees by using 3 probably. Okay, if you only start 2, then it's fine by me. Put a screenshot, explain the concept behind it, explain what you've done, and that's it. Okay, so one way around this is to use private IP addresses in order to build all of your virtual machines and have as many instances as you like basically in there. After the networking, another thing that we can do is add specific directories to share for lecturers and students separately. So the initial setup that you've done with NFS is you've created a directory and everybody has access to it. All right, you can create some distinction between different folders on the server itself and who can actually connect to that. So you can configure your VM lecturer machines to actually connect automatically in etc. FS tab onto a specific share, so lecturer shared space, and you can configure your students' virtual machines to actually connect onto the student share space onto your server. Okay, so you can do this again because you can provide more access control over what resources everybody can actually connect to and use in the cloud. A step further away from that is to actually create the user's home directories on your LDAP server as NFS roaming directories. So every time a student logs in to virtual machine student, they will input their username and password. The authentication client on your VMS will contact the server. The server will say, yes, this is a valid LDAP user, that's his username, that's his password, log him in. Oh, and by the way, his home directory is there. And then the system will try to access that home directory through the NFS share that corresponds to that home directory. And when the user logs in, they will get their home directory available to use on the server. This is particularly helpful because for the students, for example, the virtual machines should not be persistent. The virtual machine should not keep the changes that the students make on them. Okay, so this is a further step that you can take NFS. So you can create roaming home directories for the users in the network. And whatever else you want to implement, any other service that you might think about, that you might want to try and so on, you can try it. As long as you document it correctly, we will give you some mark for it. Okay, the idea is that you try to learn and try to experiment as much as you can, and we give you the resources and the help to do that. Very, very important in all of this, keep backups. Even today, we had to restore one student's Prometheus because he unceremoniously killed it. All right. So at the end of the day, when you're finished working, suspend your virtual machine, suspend your Prometheus, go into your /home VM3, VM4, whatever your username is, /VMware directory, make a copy of the TB2 Prometheus VM. Okay, that has to happen on the host computer itself after you're finished and you've suspended and you've switched off your Prometheus VM. Okay, this way, if you do make something that if you do something that goes wrong, and because these are now getting more complicated, you will do something wrong. Yeah, you don't need to worry about starting all over again and stressing about losing marks in the logbook and the previous lab sheets and all that. Okay, so please make sure that you keep backups now every week after you leave. Only one backup is enough, so don't start filling up the space, with multiple versions of TB2 Prometheus. All right, as long as you have one valid latest backup available, then that's fine. You don't need anything else. Okay. So for the 3 weeks of Easter, we will not be in class. All right. If you do get really stuck somewhere, you can send me an email. If you send me an email to ask questions, tell me which computer you're sitting on, what username you have, and exactly what the problem is, where you're stuck. Okay, I'm doing lab sheet whatever, I'm trying to do that part of the lab sheet, and I'm stuck there. This is the problem. Include a screenshot of the error that comes up, and I will try to help you. All right. If you don't make your email very detailed, I will not be able to help you, and I will have to ask questions back, and then you ask me back and ask back. Okay. So if you do get really stuck somewhere, let me know. Also, of course, don't forget that you can employ my lab assistants. They can come and help you with it. Okay. Or if you need some help explaining something, you can do that. That's fine. And the lab is open. Spend as much time as you like in it. If somebody else shows up and they want to work on your computer, please leave within an hour. Don't hog the computer. Okay, and that should be it. Okay, any questions about all this?
So except VFS, the rest of them are not persistent during that, right?
So the idea is that the lecturer virtual machines do keep their settings. However, all of this is rendered moot after you create the home directories, the roaming home directories, because you don't care. Yeah? Anything else? All right, good. So this is basically a guide for the tasks so that you know exactly what the breakdown of tasks is for the last lab sheet, and you know where you're standing when I come on your computer to assess you in the last week. All right? Okay, have a good Easter break, and we'll see you in 3 weeks.